So today we are going to discuss in this video the Coulomb's law, which is a very fundamental law in case of electrostatics, right? Already from the very beginning we are keep on discussing that the charges, when charges are at rest, so its effects, whatever the influences are happening around the neighboring charges, we are discussing, right? So that can be very effectively told by this Coulomb's law. What it is telling about charges, let us see that. If two charges are there, two charges, let us say one charge and another charge. So here if you get a doubt, charges number, one coulomb charge means it is going to billions of number of charges, right? One coulomb means. But how can we say that charge is there? Like whatever the quantity of charge may be, we are assuming it to be a point charge. Suppose if it is a 5 coulomb of charge, that 5 coulomb, how many number of charges are there in 5 coulombs? All are supposed to concentrate at that point. Like that we are assuming. So what is that charge? Let us say it is a q1, and I am assuming another charge, that is q2. q1, q2, two charges are there, and these two charges are separated by some distance. Let us say that distance is r. Then are there going to be a force? Okay, so yes, surely it is going to have some force between them. To understand very easily, I can say one thing. If we have two magnets, will there be a force? Surely it is going to have what kind of force? It can be attractive or repulsive, right? Attractive or repulsive. When it can be attractive, when it can be repulsive. So if like charges, in case of charges we are saying it. In case of magnets I am talking. In case of magnets, if like polarities, polarity magnets are there, what we can expect? We can expect the repel, they move away from each other, right? Another one, if they are unlike polarities, north south, then they are going to attract. In that case only they are going to attract. Similarly, here two charges are there. What are the polarities of charges? Here nothing is mentioned, means it is going to be treated as a plus, and here is also nothing mentioned, it is going to be plus. Then what is going to be the force between them? Yes, force is going to be there. So how much force is going to be there? That is going to be said by this Coulomb's law. So it is not only going to say on which it depends and how much it is going to be, right? So it is going to say about the nature also. We know that force is a vector quantity, right? If we are answering that force, we have to give at least two details. One is a magnitude, another one is a direction. So these two details are mandatory when we say that the force is a vector quantity. So what this Coulomb's law says? Coulomb's law says that the force between the charges is directly proportional to the product of the charges q1 and q2, product of the charges. So it is directly proportional to this. It is the first one. And what it is saying, another statement, and simultaneously it is going to be inversely proportional to the distance square. So what is that? Distance square means distance between those two charges. So that is the second statement of that law. So in that totally the force is going to be, if we combine two statements, what you can write? You can write that force is directly proportional to product of the depends on product of the two charges and inversely proportional to distance between them. So this is going to be like this from the combination of 1 and 2, and we know that proportionality is there, right? So to remove that proportionality, we know very simple thing, you remember it. So when there is a proportionality, you have to keep a constant and one equal, means simply I will remember it like this, that proportionality is going to be equal with some equal and some constant. What is that constant? Don't know. This proportionality is going to be replaced with this. So what I can write here? I can write like this, f is equals to, f is directly proportional, instead of this I am going to write like this, f is equals to some constant, some equal, instead of this proportionality I have to write one equal and one constant. What is that? C means to say constant I have written, but what is going to be that constant here? That constant is k here, that constant is k here. And what about remaining? They are like that only, q1 and q2 divided by r square. Okay, so what is this k here? We know the q1, q2 and r square and f, right? So we know that these two charges are like, means what is going to be the force of attraction? What is going to be force of attraction or repulsion? So surely it is going to be repulsive, because this is going to be pulled by this, right? So and this is going to be just pushed away from each other. ఒకదాన్ని ఒకటి తోసేసుకుంటాయి, దీన్ని అది తోసేస్తుంది, దాన్ని ఇది తోసేస్తుంది, ఎవరిని తోసే. సో దీస్ ఫోర్స్ ఈజ్ గోయింగ్ టు బి ఫోర్స్ ఆన్ వన్ first charge by the 2 by the second charge. Here it is force on second charge by the first charge. So F122 and F221, so they are going to push each other with the same quantity, but they are going to act in opposite direction. F122 equals to minus of F221. So what is going to be that force? Between these charges, surely we understood it is a repulsive, because like charges, right? So then this k is Coulomb's constant. K is equals to Coulomb's force constant. So this, how the constant value is going to be determined in each proportionalities or in physics laws, that separately we will discuss. But here for the k value is going to be decided as k equals to 1 by 4 pi epsilon naught. 4 is a constant, we know, pi is also constant, but what is this epsilon naught? What is going to become here? So it is the permittivity, electric permittivity in vacuum. Whenever we get a constant value, surely it is going to have some value, right? Constant, that is going to have some value. So what is that constant value? 9 into 10 to the power of 9. That constant is 9 into 10 to the power of 9. What is going to be that unit? What is going to be that unit? It is a k value, right? You send all the remaining physical quantities that side. So what you are going to get apart from the k? So let us write it. So this 9 into 10 to the power of units to write, I am doing this. From this only let us do it. K equals to f into r square by q1 into q2 equals to k na. అదే కదా వాల్యూ వస్తుంది. ఇప్పుడు ఎఫ్ ఈజ్ నథింగ్ బట్ ఫోర్స్ యూనిట్స్ న్యూటన్, ఆర్ డిస్టెన్స్ యూనిట్స్ meter, SI units, meter square, because distance square, R square. Charge, coulomb, into charge, coulomb into coulomb, coulomb square. Okay, so what is the unit of that? It is Newton meter square per coulomb square, Newton meter square per coulomb square. So that is going to be the value. So now in this thing, if you know this value, k value is 9 into 10 to the power of 9, how it is determined later, for which convenience it was taken like that, we will discuss later. But now what is this epsilon naught? It is the permittivity, electric permittivity in vacuum, because these charges we are assuming them to be in the vacuum. So where are these two charges? These two charges are not in any medium, these two are in a vacuum. So then in that case, epsilon naught is how much? Epsilon naught is how much? So that is going to be determined with this 9 into 10 to the power of 9 is the k value, that equals 1 by 4 into pi into epsilon naught. So if you want this, epsilon naught is how much in vacuum, then do this, epsilon naught equals to 1 by 4 into pi value 22 by 7 into or 3.14 something like you can write, into 9 into 10 to the power of 9, 9 into 10 to the power of 9. So whatever the values come when you do this, that is going to be the electric permittivity, electric permittivity. So again, if you want to get what is going to be the unit of that, again how I have done here from this equation, what is the k values units, just I have determined. Similarly, from this you can determine epsilon naught value. So just if epsilon naught you got this like this. So 4 has no unit, pi is not unit, reverse of that what is going to be happen, you can check it. So this is a very simple brief explanation about this Coulomb's law. And whenever there are two charges, between them how much force is there to determine, we use it, right? So that force is depending on this. So what is the meaning of that? It depends on q1 and q2, right? Suppose if I choose q1, q2 becomes double, what is going to be the force between them? You can check it. q1 is 2, q2 is 2, means double it become. Then 2 into 2 again 4, means if charges become double, force between them is going to be fourfold, quadrupled, it's going to be like that. So just we have to understand in how many possibilities are there, whatever changes we can do, we can understand. Okay, charges quantity have increased but distance decreased, then is it going to have, there is going to be the chance to have the same magnitude even though charges have changed, distance have changed? Yes, it can be, because even though you change this 2 and this numerator denominator you are changing, then again there is a chance to get the same magnitude of force, right? So with that we can understand what is that. In the vector form of Coulomb's law we can understand more, okay, the magnitude and direction. Still, what is the direction here? In this case the direction is the line joining the two charges, joining the two charges, along that line the force is going to act. Now is it clear? Force means I already told in the beginning, we need to give the two details, magnitude and direction. The magnitude is going to be calculated with this, right? Another one, direction is along the line joining the two charges along. And what is this side? Either this side or that side, in the same line only. It depends on like or unlike charges. That's all, right? Thank you.